This extraordinary gamma ray burst likely came from something much closer to our Earth. For all our current proficiency at studying the cosmos, the universe, there are some basic things that are still extremely difficult to do. One of those things is gauge distances, especially for random transient flashes of light. And now one of those transient flashes, interpreted as a possible burst of gamma radiation from 13.4 billion light years across the universe, has been unmasked. In two new papers, separate teams of astronomers found that the flash called GN-Z11 flash is from something much closer to our Earth. Namely, it was sunlight reflecting off a bit of discarded rock in Earth orbit. So you can imagine how close it was. In one paper, the team led by astrophysicist Charles Steinhardt of University of Copenhagen's Niels Bohr Institute in Denmark ruled it much more likely that the signal originated within our solar system. And in the second, a team led by astronomer Michael Michalowski of the Adam Mickiewicz University in Poland traced it to a piece of space junk in the vicinity of the flash, the discarded Brizem upper stage of the Russian Proton rocket. Please support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Meanwhile, the original team that reported GN-Z11 flash and speculated that it may be a gamma ray burst, led by astronomer Linhua Jiang of the Calvi Institute of Astronomy and Astrophysics in China, has stuck by their conclusion that the signal came from much farther away. He said, "This is a typical problem in astronomy. It's difficult to measure distances." This is what Michalowski told Science Alert. He said an object with a given recorded brightness may be a faint nearby object or a luminous distant object. In both cases, they would appear equally bright for us. The object in question turned out to be a very nearby piece of space junk, but its brightness was equally compatible with a huge stellar explosion at the edge of the observable universe. GN-Z11 flash was detected April 7, 2017, when Jiang and his team were conducting near-infrared observations of a distant galaxy named GN-Z11 using the MOSFIRE instrument on the Keck 1 telescope in Hawaii. In the 5.3 hours of data collected, they found a brief burst shorter than 245 seconds coincide with the position of the galaxy in the sky. They ruled out a moving object such as a satellite, since the flash occurred several hours after sundown, and ruled out known minor planets. There were none they found in that region of the sky. The likeliest explanation, therefore, was an ultraviolet flash associated with a gamma ray burst from NGZ11. Other scientists were less convinced. The level of luck needed to make such a detection would be extremely high, especially given the scarcity of gamma ray bursts detected in the early universe. Up to now, there have been just a handful, and GN-Z11 flash would be earlier than all of them detected in just a brief 5-hour observation window. Steinhardt and his team wrote in their paper, "The extreme improbability of the transient source being a gamma ray burst in the very early universe requires robust elimination of all plausible alternative hypotheses." And we identified numerous examples of similar transient signals in separate archival MOSFIRE observations, and argue that solar system objects, natural or artificial, are a far more probable explanation for these phenomena. Michalowski and colleagues drilled it down to a specific object. They carefully studied space debris, database space track, and found a discarded stage of a Proton rocket launched in 2015. This rocket, they found, was at a distance of only 13,758 kilometers from our Earth, and would have appeared in the Mossfire field of view during the time the flash was taking place. Also, in addition to this, at that altitude it would not have been within Earth's shadow, meaning that sunlight could indeed have bounced off this. Jiang and colleagues are unconvinced. The profile of the flash, they said, is different from flashes from near-Earth objects, and their calculations suggest that the Breeze M rocket stage was not as close to the field of view. It could, they said, have been from an unknown rocket, but even then, the probability of this is low, they said. They wrote, "We cannot completely rule out the possibility of unknown satellites or debris. Despite this fact, our new calculations suggest that our original conclusion remains valid. We expect we have not heard the last of this GNZ-11 flash, but as good old Occam says, if there's a simple explanation, that's probably going to be where the answer lands. And as Carl Sagan pertinently noted, extraordinary claims require extraordinary evidence." So to conclusively link GNZ-11 flash to GNZ-11, the science community is going to want to see that extraordinary evidence. For now, Michalowski seems pretty satisfied with his team's conclusion. He said, "On one hand, the existence of a gamma-ray burst in such a distant galaxy would have important consequences to our understanding of the formation of the first stars and galaxies, so I was happy that I can push science in that right direction. On the other hand, it's a pity that such an extraordinary discovery turned out to have such a mundane explanation." These three papers have been published in Nature Astronomy, with the links found in this article. This is on Science Alert. Please leave your comments. Thank you for your support.